We traditionally picture election security as closed loops, air-gapped machines, and isolated local servers operating county by county. But that model is obsolete. This map reveals the reality, the actual network topology for a single county's election infrastructure in Los Angeles. Panning across the outer edges in this infrastructure, we have to look past the local firewalls. We must map the corporate entities, mergers, and acquisitions that built these underlying networks. We do this using open-source intelligence, or OSINT diagnostics. By analyzing MTR packet routing logs, whois domain registrations, and Shodan server scans, we can trace exactly where municipal data is flowing. Traditional closed-source security audits often look at code in a vacuum, missing external dependencies. Network trace tools, however, detect the actual data exfiltration pathways operating in real time. Our forensic objective is to work backward. We take the 2025 election vendor landscape and reverse engineer the corporate history to isolate the exact origin points of foreign IP dependencies. What we find is a pattern of corporate consolidation. Critical network vulnerabilities are rarely built from scratch by current vendors. They are inherited over time, creating systemic data sovereignty risks that conventional audits ignore. This corporate structure flowchart illustrates the 2025 baseline. At the top level, we have Liberty Vote, which recently acquired Dominion voting systems, operating alongside KnowInc and their widely used PollPad electronic poll books. Beneath KnowInc, we find BPro. These two merged in 2020, integrating BPro's total vote election reporting system into KnowInc's infrastructure. Going back another year to 2019, KnowInc acquired a voter registration business from a remote voting company called Votum. At the bottom of this chain sits a Michigan-based vendor named Konnech. In early 2016, Votum acquired Konnech's mobile voting system, software platform, and underlying code. This is the mechanics of inherited code. When one tech company acquires another, the foundational code bases and API dependencies don't vanish. They are absorbed into the parent company's ecosystem. If the original code, like Konnech's 2016 platform, contained insecure data handling practices, those vulnerabilities don't stay isolated. They scale horizontally across the parent networks that purchase them. To measure the threat, we have to analyze the public asset exposure of that root company, Konnech, using OSINT subdomain mapping. This data table lists the localized subdomains assigned to Konnech's poll chief software. Notice the entries for Boston and Minneapolis. These are portals built for specific U.S. jurisdictions to manage poll worker data. The subsequent page reveals the true scale of this architecture. We see a continuous sprawl of demo and login portals for jurisdictions like Edmonton, Allegheny, and Denver, all running on the exact same domain structure. Further down, records show centralized subdomains like api.pollchief.com, linking municipal sites back to core servers. Zooming into administrative entries like PC-admin reveals how a single API breach provides an immediate backdoor into dozens of local jurisdictions simultaneously. What appears to a county clerk as a secure, localized system actually relies on aggregated nodes. This architectural design multiplies the risk of any single server breach across the entire network. We track the geographic journey of the data leaving these subdomains using network routing analysis, specifically MTR traces. During the 2020 and 2022 election cycles, independent researchers ran trace routes on poll chief logins to see exactly where the packets traveled. This visualization traces the path of a sample data packet. It originates from a U.S. county, moves through several routing jump nodes, crosses the Pacific, and terminates at specific IP addresses in the 202.97 range. Those destination IP ranges are registered to China Telecom and China Unicom. Both entities share documented partnerships with Hongzheng Technology, a subsidiary of Konnech operating out of China. Analyzing these specific packet drops, independent OSINT tools calculated a 55 to 70% probability of man-in-the-middle interception occurring at these foreign network hops. Routing U.S. election records containing personal identifying information through foreign infrastructure explicitly violates county data localization contracts. More critically, it exposes the entire inherited supply chain to overseas espionage. The exposure does not end at the election office. Modern election platforms use application programming interfaces, or APIs, to continuously communicate with state databases, including the DMV, the Postal Service, and the Social Security Administration. Threat intelligence platforms like AlienVault have flagged severe vectors in these types of systems. For example, specific URLs associated with Smartmatic's VSAP hardware have been linked to known Trojans hosted in Panama. This animation illustrates lateral network movement. When malicious code breaches a porous application, it bypasses firewalls, seeping horizontally into highly secured adjacent government databases. These API cascades transform a minor vendor breach into a systemic threat to critical state infrastructure. The most significant vulnerability in U.S. election infrastructure lies in the persistence of compromised legacy architecture hidden within consolidated vendor monopolies. Returning to the LA Vote macro network graph, we can trace how this scales. If a compromise originates at an edge node, like an old module inherited from Konnech, it aggressively traces through integration lines directly into the central infrastructure holding the voter rolls. That initial codebase, written a decade ago and hosted on unsecured foreign servers, is now digitally intertwined with systems managing millions of voters across the nation. The industry's reliance on constant mergers and acquisitions guarantees that legacy vulnerabilities are amplified and distributed across the country, rather than quarantined and patched. Relying strictly on localized perimeter defense, firewalls at the county level, is mathematically insufficient for protecting a globalized software supply chain. This terminal display outlines the necessary protocol shift. First, we need continuous mandatory code audits led by CISA, specifically targeting all third-party API integrations and legacy source code hidden within merged platforms. Second, any corporate mergers or acquisitions involving election management software must trigger mandatory scrutiny from the Committee on Foreign Investment in the United States. Third, vendors must be held to strict foreign patent disclosures and uncompromising data localization mandates to instantly block any overseas network routing. The integrity of the vote depends on the integrity of the code. Securing this critical infrastructure requires treating invisible corporate supply chains with the exact same forensic scrutiny that we apply to physical networks.